Hey guys, this is Miss Fantassel. So I'm posting this video just to kind of help some of you that are really struggling with rational expressions and functions. I know that rational expressions are not easy, and especially when you're, trying to learn them online. So I get it, and hopefully this video will help clarify some of the confusion that's happening. And if not, please reach out to me, and I will work as best as I can to help you to figure it out. So this first section is really looking at just what a rational expression is, how to find the domain, and how to simplify. And so it starts off with just what is a rational function or expression. So when we use the word rational, we're always talking about a fraction. So an expression or a function involving a fraction. Here are some examples of rational expressions. So 3 over x plus 4. I'm not going to list them all, but there they are, right? So each of these is involving some type of fraction. So how do I find the domain of this type of function? So what you're going to be doing is you're going to be looking for restrictions. And what I mean by that, so they call them restrictions. I've also seen them called exclusions, but it's basically looking for what x cannot equal. And we know that a 0 on the bottom of a fraction, if you were to plug something divided by 0 into your calculator, you would get that error. And that's because we can't divide by 0. So 0 in the denominator is going to be where your restrictions are. So a couple of examples. For the first example, it says find the domain of each. And so for part A, we're going to find the domain of this. And so I'm always going to start by just taking my denominator and saying that it does not equal 0. Because I know that the denominator cannot equal 0. That's my restriction. When we're looking for domain, though, we're specifically looking for what x cannot equal. So I don't want to know what x plus 4 cannot equal. I want to know what x cannot equal. And so to finish this out, I'm going to solve for x. And I'm going to do that by just doing the opposite. So I'm going to subtract 4 on both sides, and I get x cannot equal -4. So that's one way that you can write the domain, is x cannot equal -4. But you also might see in interval notation. And so what it looks like in interval notation is you'll see a parentheses. This parentheses means that it's not included. So you're basically writing out what is included in the domain. And we start from as small as we can get to as big as we can get. So we're going to put a negative infinity here because it can be -100. You could plug in a -1,000 and -1,000,000. All of those things are acceptable. The only thing that we can't plug in is this -4. That's right here. And so I just put a negative infinity there. The reason why we use the parentheses is because infinity, it's not really a value. It's more of an idea. And so nothing can actually be infinity. There's no value to it. So whenever we're using infinities, we always will use a parentheses instead of a bracket. Mostly in rational functions, you'll see parentheses and not brackets. So I'm not going to go too deep into that, but just know that a parentheses, like in this case, means it doesn't include that value, and a bracket would mean that it does include that value. Okay, so it goes from negative infinity, and you can plug anything in all the way up until -4. So this comma right here means 2. So negative infinity to -4 is something that you can use, but remember we can't use -4 because that's our restriction. So we're going to put a parentheses here. So our domain is that anything can be plugged into that function from negative infinity all the way up to -4, but we can't actually use -4 because of our restriction. So that's why the parentheses. And then we're going to join it up because we also can use anything after -4. So that little u right there It means or. It's also the union symbol. So it's like, think about marriage, you're like joining them together. And so -4 is where it would start. And you can use anything after -4 all the way up to infinity, could all be included. And so your restricted value right here is what breaks up your interval, if that makes sense. And you'll start to see this same like pattern over and over again. All right, so let's go to the next one. So either one of these notations is acceptable. I wanted to cover interval notation just in case you have a multiple choice question. I want you to be able to pick out the right domain, and so I want you to be able to understand what that even means. But if you're actually writing it yourself, this is totally acceptable. And I don't know, I feel like for rational functions, that first one is even a little bit easier. All right, so let's go to the second one. I'll use another color so that we don't get confused. But now I want to find the domain. So again, I'm just going to take the denominator and I'm going to say that it doesn't equal 0. The problem here is that I have an x squared and I have an x. And I know I can't combine those because they're not like terms. So I can't just do what I did last time and get x by itself by moving things over, because I'm going to end up getting stuck. Once I move the +4 over. I'm not going to know what else to do. So whenever you have, this is a quadratic. We know it's a quadratic because our highest exponent is 2. And so whenever we have a quadratic like this, to solve for what would be 0, we want to factor. So I wanted to do just a quick review of factoring. So I wrote down the steps here, and I'll kind of go through this first one with you. So I just took the denominator of the last problem. You'll see that they're the same: x squared minus 4x plus 4 and x squared minus 4x plus 4. Now, I do know that there are faster ways to factor, but just for the simple fact of making this video shorter and not showing you so many different ways, I'm going to show you the way that will work pretty much every time. So that if you get something that's harder than this particular problem, that you'll know what to do, because I know that there are shorter ways to do this, but they don't work every time. And so your first step is going to be to multiply a and c. So you'll notice that we have the form here: ax squared plus bx plus c. A is always the number in front of x squared, b is always the number in front of x, and c is always the constant by itself. Now you'll notice that my x squared doesn't have a number in front of it, so it's automatically a 1. So multiply a and c. So I'm going to multiply, that's my a, that's my c, so 1 times 4, which is equal to a +4. And I'm making sure to put the positive there because that is going to matter as we're going through this, so I want to make sure that I'm just paying attention to my signs. All right, so 1 times 4 is 4. Then it says list the pairs of numbers that multiply to give you the product of a times c. Well, I already did a times c. Remember, product is just the result after you multiply. So this is my product of a and c. So +4, and I'm going to list the pairs of numbers that would multiply to give me 4. Again, this is easy because it's a low number, but I like to do this especially as the numbers get bigger and bigger. And it's just easier if you list them out to find what you're looking for. I always just start with the smallest number and work my way down. So 1 times 4 would give you 4. 2 times 2. And then it would just repeat. I'm not going to rewrite 4 times 1 because it's just the same thing. So once you get to where it starts repeating, you can stop. It's a +4. So a big mistake that I see is I see students that they see that +4, and so they automatically think that all the numbers are positive. But remember, a negative times a negative can also be a positive. And so what you're going to do is you're going to If this number is positive, you're going to look at the middle, and that's going to tell you whether they're both positive or both negative. So this number is negative, so both of my numbers have to be negative, and I'll explain why in a minute. Now, if it was a -4 initially, that's another story, and we'll see that actually in the next example, so I'm not going to go too far into that yet. All right, so I have my pairs listed. And so now step 3, it says circle the pair that also adds to give you B. So the reason why we made them both negative is because if they were both positive, my numbers, they're not going to add to give me a negative number. So that wouldn't make sense because they have to multiply to give you this product and they have to add to give you the middle. So they'd have to both be negative. A negative times a negative is a positive, and a negative plus a negative is still negative. You just owe more. So the two numbers that will add to give me -4 are these two right here. Okay. So step 3 is done. Then it says to rewrite the expression using the circled pair in place of B. So I'm rewriting, I did not mean to do that. I'm rewriting this expression, but instead of the middle, I'm going to use these two pairs. So what I mean by that, I have x squared, that stays the same, but I'm going to write what it was above so we can see. Okay, instead of this piece, I'm going to use my two numbers. So -2, I'm going to put the x with it still, -2x plus 4. And so you'll see that I really didn't change the value. If I added these two numbers back together, I would end up with -4x. All I did was rewrite it to make it look the way I wanted to. So I didn't change the value. That's really important. Everything is the same other than the middle. So that's there, and I just broke the middle up. Okay. Now we're going to split the expression into two parts. So I'm going to look at the first part together and the back part together. And what I'm going to do from here, so that's step 5. Step 6, I'm going to factor out the GCF. The GCF stands for the greatest common factor in each part. So first I'm just looking for the greatest common factor here. Well, the greatest common factor, or the biggest thing that both of these have in common, is an x. So I'm going to take an x and put it in the front. This is the opposite of distributing. So when I'm pulling it to the front, I'm dividing. So I pulled an x out of this part, so I still have one x left. And I pulled an x out of this part, so all I have is the -2 left. Okay. Notice that if I redistributed, I would end back up with what I started with. So again, I haven't changed anything. Now I'm going to go to the second part, and I'm going to look for their greatest common factor. So the biggest thing that goes into 2 and 4 is 2. Neither one, well, only one of them has an x, so I'm not going to include an x in the greatest common factor this time. Just a 2. Whatever sign comes first, that's the sign that's going to be pulled out. So I'm actually going to pull out a -2. And so -2x divided by -2 would just leave me with an x. And then +4 divided by -2 is going to leave me with a -2. Okay. We're almost done. So for this last step of factoring, this is a good place to stop and check yourself. These two parentheses have to be the same in order for you to do the next step. If they're not the same, it means that you did something wrong. So either maybe you pulled out a positive number when you should have put out a negative number, or maybe you pulled out a common factor, but it wasn't the biggest common factor. So go back and look for something bigger. But either way, these two parentheses have to be the same. So now my first factor is going to be what's in my parentheses, x minus 2. And I only write it once, so that comes from here. My second factor is going to be to group the outsides. So I just grouped the insides. Now I'm grouping the outsides. The outsides are what's in front of my parentheses. So x minus 2 is my second factor. And so now I'm going to go back. So I know that x minus 2 times x minus 2 is what this looks like factored, and I know that cannot equal 0. And so I'm going to look at each factor separately. So I'm going to just split them up. So that means x minus 2 cannot equal 0. Or normally I would put the second factor, but because the second factor is the same as the first factor, you don't have to like write it again. But if it was something else, you would also say that that doesn't equal 0. I'm going to get rid of those parentheses. And now we can solve just like we did for part A. So I'm going to add 2 to both sides. So x cannot equal 2. So that's my domain. If I wanted to write it using interval notation, I could write negative infinity to 2 and 2 to infinity. Okay. Let's look at the next problem. So for C, I'm going to do the same thing. So I'm going to take the bottom and say that it doesn't equal 0. So x squared plus 2x minus 3 does not equal 0. I'm going to go through my factoring again. So I'm going to come back to this other page. Whoops. And I'm going to factor. So again, I have a 1 in front of x squared that I don't see. Start off by multiplying a times c. So 1 times negative 3 is negative 3. And so this time I'm listing my numbers that multiply to give me negative 3. So that's just 1 and 3. It's a negative number, and so in order to multiply to give you a negative number, one number would have to be positive and one number would have to be negative. So in this case, they're not both going to be positive or both negative. I have one of each. The way that I'm going to tell which one is which is I'm going to come and look at the middle. My middle number is positive. So if my middle number is positive, that means that my bigger number has to be positive. If my middle number was negative, then my bigger number would be negative. And so that's my little trick for determining which one. Then I'm going to circle the pair that adds to give you b. So negative 1 plus 3 gives us b. Then we're going to rewrite our expressions. So initially we had x squared plus 2x minus 3. And now I have x squared minus x plus 3x minus 3. So again, I just split up the middle, split it into 2 parts, factor out the GCF of each. So what do x squared and x have in common? Well, they have an x. And when I pull out an x, I have 1x left here. And x divided by x is 1, so it's going to be minus 1. So it's not 0. And then I'm going to look at the second part. So what do 3x and 3 have in common? Well, they have a 3. That's the biggest number they have in common. 3x divided by 3 is 1x. And 3 divided by 3 would be negative 1. And now I'm going to do my factor part. So I'm going to group my insides. So x minus 1 is one factor. And then my outsides are my second factor. So x minus 1 times x plus 3. So now I'm going to go back. This is x minus 1 times x plus 3 does not equal 0. So that means x minus 1 cannot equal 0. Or x plus 3 cannot equal 0. And so x cannot equal 1, or x cannot equal negative 3. And if I was going to write this in interval notation, I would say negative infinity to negative 3 would be my first number from least to greatest. Negative 3 to 1. forgot my U. Sorry. Sometimes I get slappy. And then 1 to infinity. So this time it got broken up in 2 places, at -3 and then also at 1. So for part D, I'm going to do the same thing. So I'm going to take the denominator and set it equal to 0, or say that it can't equal 0. Except this time I don't have a variable, so we know that 8 is never going to equal 0. So for this one, there actually isn't a restriction because there's no variable there. 8 doesn't equal 0, and it's never going to equal 0. So for this one, we would say, for D, our domain, we could do this a couple ways. We could say it's all real numbers. There's a symbol for that. It's like a double R. So you also could do that. I just do 2 lines and then make an R. Or you could write that your domain goes from -infinity to +infinity with no breaks in between. So it pretty much includes every real number. How to deal with a negative. So sometimes you might come across a negative in the front of your fraction, and it's just easier to take that and just move it either to the top or the bottom, but not to both. And make sure when you move it, you're making the whole thing negative, like the whole top or the whole bottom. So you want to use parentheses. So I can move it to the top, which would look like this. And then I can distribute my negative. Or I could have moved it to the bottom. So I could have written it as 2x minus 1 over -3 plus x, and then distribute. And so these are equivalent, and they're the same thing, they just look different. I tend to always move mine to the numerator. I just like to be consistent, but either way is fine. Another mistake that I see, so your domain is based off your original, not your simplified expression. So before you simplify, you always want to go through and write your domain. You know what? I think I missed a piece of this, actually. No. I did. Okay, sorry. So one thing with simplifying rational expressions, the biggest mistake I see is I see students that want to cross out anything that's on the top and the bottom. Be careful. You can only cross out if they're separated by multiplication. So this is multiplication, this is multiplication. So it is okay to cross these out because that's multiplication and that's multiplication. It is not okay if it's separated by addition. So not okay to cross that out. It's not okay to cross these out. It's separated by addition. Or they can both be separated by addition. Still not okay. Okay, so it has to be separated by multiplication. All right, yeah, so your domain is based off of your original, not your simplified expression. So the first step you're going to do is you're going to factor the numerator and the denominator. Now, these are a little bit different than just our quadratics, but there's only 2 terms in each. So my initial thought is that I'm going to just, I just went blank for a minute, sorry. Yeah, that I'm gonna just try to factor out a GCF right away. So you can always factor out a GCF before factoring like I showed you earlier. So on the top, I'm gonna look for what they have in common, and it looks like they have a y in common. So I'm gonna put the y in the front. So I took out the y, which means I only have an x left. And then I have a 4 left, and I took out 1 y, so I still have 2 y's left. Now for the bottom, so it looks like they have a 2 in common and an x. So 2x is going to go in the front. I pulled out the 2, I pulled out 1x, so that means I have 1x left over. And then for my second term, I pulled out a 2, so you're dividing by 2, so minus 4 left. I pulled out the x, so that's gone, and I have a y squared left. Okay. Excuse me. And so now that I'm here, before I simplify, I'm going to write my domain. So my domain, I know that any factor cannot equal 0. So 2x is a factor, so that cannot equal 0. Or x minus 4y squared, that also cannot equal 0. And then I'm going to solve. So if I solve this first part, I'm going to divide by 2. 0 divided by 2 is 0, so x cannot equal 0. Or here I have 2 variables, so I'm just going to solve for x, and I'm going to leave my variable alone because I really care about what x can't equal. So I'm going to move this whole piece over. So x cannot equal 4y squared. It's okay if there's a variable there. I'm going to leave it. Okay. Now that I've listed my domain, now I can go through and cancel out any factors that the numerator and denominator have in common. So they have x minus 4y squared in common and x minus 4y squared in common, the whole thing. So the whole thing gets crossed out. And then I have y over 2x left. So y over 2x is my simplified expression, and my domain is that x cannot equal 0 and x cannot equal 4y squared. Well, I really hope that this helps. I'm going to post more videos to help you. So do me a favor, please let me know if this does help you, so that I just have feedback on if what I'm doing is working for you. And if it doesn't help you, then, also give me feedback, because we can work through it and try to figure out a way for you to get whatever misconceptions you're having. All right, well, I hope that you guys are staying safe and have a great day.